Hello everyone and welcome back to my channel. In our last video we talked about SQL Select, and in this video still on SQL Select, but we are going to do a lot of practice. Basically using SQL Select statement, we'll just go from beginner level to a little bit intermediate levels. So that means we'll be using the keywords select, from, and where. And in some examples, we'll just add the joins. I do know that I did not really talk about the join keyword from the last video, but we will introduce it in this video and then talk about it extensively in our next video and the other ones. So if you haven't subscribed to my channel, please subscribe. It's totally free. We introduced the SPY schema database in the last videos. I can't remember which one. Today I will introduce an additional table. Let's call it the book schema. It's going to have three tables, just as you can see on my screen. This is it, the book schema. It's going to have three tables: authors, books, and publishers. And as usual, these tables are going to be related, right? So the first thing you want to do is to create these tables. I'm going to upload the CSV files for each of these tables in a GitHub account. I'll leave the link in the comments or in the description below, right? So I would upload the CSV files for these three tables in a GitHub account. I'll leave the link for you in the description below. All you have to do is create this table. So I'm just going to show you the domain of the columns of these tables so that once you create it, you can download that CSV file and then import. I showed how to import tables in the video where we talked about how to set up for the SPY database. So maybe you can just go back and look at it. So the first table, let's look at the books table. So I've selected everything from schema.table name, book.books, and this is what we have. So this means that the book table has 1, 2, 3, 4, 5, 6 columns. The ID, the title, the page count, the genre, the author ID, and the pub ID. And you can see the data type of each of these columns. You'd need this to create a table. We talked about creating a table before now, so you can just look that up. So let's look at the authors table. So this is the authors table. It has 3 columns. So you can just look this up and then create the table. Like I said, download the CSVs and then import it in your pgadmin 4. The last table we'll look at publishers. Publishers. Great. It has just 2 columns. So let's start already. We are going to start from the SPY database. So what we are going to do is I'm going to say the query in English language, and then we are going to translate that English query to an SQL query. So we're just, trying to flex our muscles. This is a practice video. So if you practice with me, I'm sure in no time you must have built your SQL skills. Okay, so the first query would be in English. We want to select all agents and their details from the SPY schema. And if you remember the SPY schema, let's go there. This is the SPY schema. It has the tables. It has about 11 tables. That's a lot. So the English query is select all agents and their details from the SPY schema. Select all agents and their details from the SPY schema. So the SPY schema has the table agents, right? And this is where we have all agents and their details. They are all in table agents. So to select all the agents and their details, you simply say select star, star meaning all, from the name of the schema, that's spy, and the name of the table, that's agent. Agent, yes, agent table. So once you run this, you have selected all agents. These are all the agents and their details. So that's the first one. So how about this second one? Find all affiliations and their titles. Find all affiliations and their title. My first bet would be to check the affiliation table. I just want to see the columns we have there. So let's see the affiliation table. So the English query says find all affiliations and their titles. So this is affiliation name. These are the titles, right? So yeah. So these are all the affiliations and these are their titles. Um, in fact, it comes in additional column, description, affiliation ID. But if you just wanted to select only the affiliation name, which of course is the affiliation title, you could just say, instead of star, which selects everything, you just say affiliation slash underscore name. You run this. Here you go. You have all the affiliation titles. So let's do the third query. List all themes and their meeting frequency. So the first thing I would do for this query is to check the table theme. I want to list all themes and their meeting frequency. So let's see what we have in the table theme. Oh no, I want to choose everything. The query says list all teams and their meeting frequency. So I just want the team name and their meeting frequency. So this means I just want to say so this means listing the unique or the particular columns that we want after the select keyword would give us the exact list of teams and their meeting frequencies. So let's just run this. So we have, these are the list of teams and these are their meeting frequencies. Okay, let's translate from this SQL to English. I'll just paste it over here. So translating from SQL to English, select distinct. So we have the keyword distinct, security level from security clearance. So if to translate this to English, this would mean that we wanted to retrieve the distinct keyword gives us unique output. That's it removes every repetition. So it gives us unique security clearance levels from the security clearance table. Let's try the next one. We want to translate this. This is an English query. We'll translate this English query to SQL. So let's look at that. We want to return a table with all columns from the table agent. We want all columns from the table's agent. So this is a star. We want to return from all columns and table security clearance implicitly joined. So I'm sure we've talked about implicit joins. So this means at the from keyword, we want to put comma the next table. So for an implicit join, we do not use the keyword join. So we simply attach the table name in the at the from keyword. So we have from security clearance, security clearance, where the column city has the value London. Okay, so now this means we would have a where keyword where the column city has the value London. So where city equals London. And maybe we should give this an alias. Let's call the agent table. Let's give it an alias A. Let's call the security clearance table alias SC. So we know that the city column is in the agent table. So we want to say A the city is equals London. Let's see whether we have a London and the column SC level has, okay. So we use the and, there's under, okay, let's run this. Oh, we didn't specify the schema, so spider security clearance. So we have no data that meets this condition. So just double check and let's see. Let's see what happens here. Let's look at the spy the security clearance table. Security clearance. Let's look at that. Spy, oh, from. Okay, so we can change top secret. Yeah, we have top secret. Yeah, there is. Okay, let's look at city from agent. Let's see. So what I'm trying to do right now is just to confirm that there actually exists top clearance and security clearance level and London in the agent table. So let's see. We could just use a where statement, right? Where C equals London. Let's see. Yeah, there are. So this means from our original SQL translation of this English query, there is no, let's run that again. So no data comes up. So this means there is no agent from London or in the city of London that is a top secret agent. So there is none. Let's look at under query. Let's look at under query. So for the next one, let's translate this English query to an SQL query. We want to return the agent ID, the first name, last name. All of these are in our agent table. As you can see, we have agent ID, first name, last name from the agent table. So we can start with that. We just name them. we want to select the agent ID, the first name, last name, city and country, okay? City and country from spy.agent, from spy.agent. What else does it say? Where the agent is an alpha team. Okay. So the names of the teams where the agents belong are not in the agent table, right? So that means we need to find the table where that information is, and then let's use an implicit join. Implicit join means we aren't using the join keyword, but we are doing a join still. So we need to find what table that is, and then sorry about that. We need to find what table that information is, and then implicitly, in this case, join. You could explicitly join it, but we haven't talked about explicit join yet. So we want to implicitly join it with the agent table, and then we can attach that where statement. So my guess is that this should be in the teams table because that's name of team. So that's team name. So just like we did in the last example, we want to use a comma, then the name of the table, spy.team, right? Right. Spy.team. So let's use an alias as usual. Let's call a spy.agent A, spy.team, let's call it T. And we want to so now we need to make a connection between the two tables, and we make that connection still using the where statement. So we need to find a column in the agent A that references the team table or vice versa. So let's quickly look that up. The team table has team ID, team name, and meeting frequency. And the agent table has agent ID. So none of the columns reference each other. This is team ID. This is agent ID. None of them reference each other. So we need to find another table that we can use as a link between these two tables. So the only purpose that table serves would be to be a link. So let's check the team relationship table. Where's that? Yes, it's down here, the team rel table. What columns does it have? So it has the agent ID and the team ID. So it means we can connect these two tables using the team rel. So let's add that here. You have spy dot team rel. Let's give it an alias tr. So we want to connect those columns here. So we can say that a dot agent ID, where a dot agent ID is equals teamrel dot, I think it has agent ID, teamrel dot, yes, agent ID, and let's see. So now that we've connected agent, this is ID, to teamrel dot agent ID, let's see, and we have teamrel dot team ID equals, let's see, team dot team ID, and now we add the last conditional, another and. Agents is an alpha team, so All right, let's understand this. So we want to return agent ID, first name, last name, city, country from the table agents. And we checked our table agents. It has all of these columns. So we wrote a select statement for it from spy.agent, and we included an alias just in case we need to reference um, the agent table again. We don't have to type out agent. And we wanted to list these out for where the agent is in alpha team. So um team, the name of team is in another table. It doesn't reflect in the agent table. So we had to find that table. It's in the team table. But then after finding out that we could get the team name from the team table, we did realize that there was no way to link the agent table and the team table because they did not have any columns that related or that referenced the other. So we had to find a table that could serve as a link between the agent and the team table. So that table was TeamRel, and that's because TeamRel has agent ID, which is found in the agent table, and it also has team ID, which is found in the team table. So it's very important that after you do an implicit join from everything on this line is an implicit join. It's just separated by commas. We don't have to use the keyword join. You link, you specify in the where keyword or in the where statement, you specify what columns references the other. So from TeamRel, um, TeamRel.agent ID reference is agent dot the agent table, that's a.agent ID. And also from the team ID references the team table, team ID, right? So after you've established this link or these references, you then include the conditional in the English query. We want an agent in the alpha team. So this means in the where statement, we only want to write out or to select data for team alpha. So let's run this. Let's see, line 1, agent and it's ambiguous. Oh yeah, good catch. So because team rel also has an agent ID and agent table has an agent ID, this is why agent ID is now ambiguous. So this is the whole point of giving your table an alias, so you can label the exact table any column comes from, especially when that column appears in two different tables. That column name appears in two different tables. So let's run that again. Yes. So now we have agent ID, first name, last name, city, and country. And for every agent that we have in this table, they all belong in the alpha team. As a matter of fact, if we included that's t dot team name, and if we run this again, we'll see that all of them, as you can see here, belong to the alpha team. So let's look at the next English query. We want to change this English query to an SQL query. So let me paste this. What are the team ID and meeting frequency for the alpha team? So let's figure out how to get that done. We want to find the team ID. So, and we know that the team ID is in the teams table, right? So let's say from spy.team and alias t. So let's quickly link this because it's from the team table. So we want to find the team ID and the meeting frequency, and meeting frequency is also in the team table. So so we have t dot meeting frequency for alpha team I'm sure yes, we have the name here. Um, so we'll quickly just create a where statement. A where statement. So here we have where team name, where t dot team name is equals alpha team. So when you run this, so for team ID, for team with team ID 33, they are in the alpha team and they're meeting frequencies annually. Let's look at yet another English query. What countries has agents with classified or secret clearance? So I assume these are the names of clearance levels. Let's quickly check out the security clearance level. You should have as column names, yes, the names of the levels. To be extra sure, let's just security clearance. So we have classified or confidential. So yeah, let's change this to confidential or top secret. Let's change this to top secret and let's change this to confidential. So we want to find out what countries have agents with confidential or top secret clearance. So we have the country in the agents table. So we can start by saying select country from spy.agent from spy.agent, and in the let's confirm in the agent table we do not have any information about the agent's security clearance level. So that means we have to add another table. And the table where we have security clearance levels would be the security clearance table. So we're just going to add that. Okay, so I'm going to write this query using the implicit join and the explicit join. So we might as well start introducing the explicit join. But first, using the implicit join, it simply means you just say spy dot security level security clearance security clearance. Let's give it an alias SC. Let's give our agent an alias A. So this means A dot country. So we want which countries have agents with this or this. So um we've done an implicit join. Now remember we have to connect the columns where there are references. So let's check. We have security clearance ID and we don't have anything of that sort that references that in the agent table. That means we have to find another table from where we can, let's see, um yeah, we don't seem to have this. So we need to find another table that can from where we can create that link between the agent table and the security clearance table. So let's look for that. So we definitely want a table that has, let's see, security levels. Um, Definitely not the skills level. let's see the missions table. So yeah, the mission has access ID, which references the security ID, and it has agent ID. So yeah, we can use that. So we have spy the mission. Let's call that M. Alias is M. So let's start that link. Um, the mission table has agent ID, which references a.agent. So we can say m.agent ID equals aim.agent ID. 1 minute. Yeah, m dot equals a dot agent ID. Oh, underscore agent ID, and m the access ID equals where do we, yeah, it's equals x the, I believe that's just to be sure, security clearance, yes. And the last one we want, so we have want, and so this is for the conditional in the question where the agent has is either so we want the this level sc underscore level. What's happening to my underscore level? Yeah. So where this underscore level is equals could be confidential or it is top secret or it is top secret. So let's run that. I hope this is pretty clear. So we wanted the names of the country where agents have either confidential security clearance level or top security clearance level. So these are all the countries where these apply. And as you can see, there are some duplicates. So to remove that duplicate, I talked about the distinct keyword. So you can use the distinct keyword. The distinct keyword. Yeah, so now you have unique countries, and altogether there are 18 countries where we have this condition. I hope this makes sense. If you have questions, you can just put it on the comments and I can go over this again. So let me quickly write the same thing. This is an implicit join. So I'm just going to write the same thing but using an explicit join. So let's go. The same thing, I want to select country, and country is in the agent table. I'm just going to write it from scratch. So from spy.agent, I want to give it an alias A. So I'm going to link it to this column because this country column comes from the agent table, right? So so at this point, so what we do, we use still the same reason. We want agents from that have confidential top level security clearance level, but these are not in the agent table. So we need to find the table where they are. And if we can't find a way to link that table to the agent table, we find another table that would just serve as a link. So that's the same thing. But in this case, instead of saying from and then comma all those table names, we use the join keyword. So we say join the name of the table. In this case, it's going to be Let me just copy this. It's going to be join this table. Then we have on. You have to join it on something, right? So let's see. Let's see. So we can't join this on something yet because these two tables don't have a relationship. So I guess we should start from this one first. So let me copy that. So this goes here. So I want to join this. Now I'm joining this on. I want to join this to this first one. M.agent ID equals. So this is where I join it. M.agent ID. And for security clearance, I want to join this on m.access. So this is the join. Then now I can write my where statements with only these expressions. Okay, so this is it. So I'm just going to delete this. Now let's run this one. And we got, let's see. Yeah, okay. Let's execute query. So, okay. Let's add the keyword distinct because we can see some repetitions. China, China, China. So we add this and we have all of these countries that have all of this. Okay. So one thing it's important for me to add that writing explicit joins is better than writing implicit joins. And from my results, I also did want you to notice one thing. In our implicit joins, we had 18 countries, and in our explicit joins, I believe we had 17 countries. So I needed you to notice this. This query where this last condition is in a bracket would give you a different result from when we don't have this bracket. In the first example we did not have this bracket. But when we have this bracket, this is evaluated as 1, which is what we want actually. But without this bracket, you have this as an evaluation, this as an evaluation, before we have this as an evaluation. If you think about it like bod maths, that the bod maths, right? I think that's what we call it. Order of operations in mathematics. That makes sense. So with this bracket, it means this is evaluated as 1, which is what we want. So now we see that when we run this, we have 17 also instead of 18. But when we remove this bracket, we should have about 18. So the difference is in the order of operation. So you see we have 18 here. I just needed to mention that so that you're careful when you're writing an implicit join. But overall, writing explicit joins, they are just more standard. I think we should take one more example from. We should take one more examples from the spy table. We've had a lot of examples already. So we have a really strange query. We want to find out what pairs of agents have the same first name and last name. So this would mean that we want to find out the names, any name, first and last name, that two agents share. So let's see how to write that. So first of all, as always, we start with select. We want to select from our agents table. We want to select first name. We want to select last name from spy.agent alias A. So let's go ahead to link this a dot. Okay. So we want to, what pairs of agents have the same first and last name? Wow. So how do we write this? So we want to select first name, last name. So because agent ID is unique, right? So even if two agents had the same name or the same details, at least their agent ID will be different. So let's also select agent ID. So we have a dot agent ID. So we want to select this from the A table, right? And there should be a where statement where the agent ID. Hmm. So yeah, the correct approach would be to join two copies of the same table, because if you do not join two copies of the same table, um, it's going to be hard to compare the names. So look at it like you have a table of names and another table of names, and by the time you join them to become one table, you want to pick out from different columns that have the same name, which names appear twice. So I think that's the trick we are going to use. So I want to get this from the agent table, and let's use join, explicit joins now. We want to join another copy of the agent table. Let's call it AG on, let's join using the first name is equals AG dot first name. Okay, so as usual, we want to join the both tables on columns that reference each other. So I hope this makes sense. So where, let's say a dot agent ID. So to make sure, I just hope this makes sense. So when you join agent table to another copy of an agent table, remember, once you use join, or once there's whether an explicit join or implicit join, you want to connect the rows that reference each other. In this case, because we are looking for two people that have the same first name and last name, we want to connect the first name and last name columns to each other, right? So once we connect that, we want to now use the agent ID to check for difference in agent ID for each connection. So we can say where agent ID is a dot agent ID is less than ag dot agent ID. So let's see what that gives us. Let's run that. Oh, I'm missing something. What's that? Line 3. Let's see. Oh, okay. I'm supposed to have spy dot. Oh, wow. Oh, we do have a lot of repetitions. Let's use the keyword distinct. But from this table, I see Alec Allen twice. So there is an agent ID 339, agent ID 293. They have exactly the same name. So let me quickly adjust this Let's use distinct. I can't even spell. Okay. So we have 540 agents. Wow, bear the same name. Wow, that's confusing, but okay. Wow. Okay, so I also want to, let me add ag.agent ID, right? Right, okay. So agent number, agent ID 91, agent ID 962 bear the same name. James Quinn, these two agents bear the same name. Wow. John Ryan, Sarah Trevelyan. Wow. Okay. Ah, this is surprising to me. So let me also add that just in case you're working on a command line and you cannot always see on a GUI the number of rows, you can use the count keyword. So the count keyword actually counts all these values and give, let's see, count. Hmm. Why is SQL mad? Why is it complaining? Hmm. Oh, let's see. So when you add, let's see. Right. So we'll just do one more example. One more example. Let's from the spy table. This is a lot. This is an English query. You want to change it to an SQL query. So what are the first names and the last names and city of all agents who are on at least two teams? So first names, last names of agents who are on at least two teams. Let's see. First names, last names, city. So let's see. City. What else? So the other part of this query talks about teams, and that means we need to find a table that talks about teams. The team table has the team ID column, which has no relationship with the agent. I'm correct? Yeah, has no relationship with the agent column. So we look to see if we can find another table that has a connection to teams while also having connections to the agent table, and that should be the team rel because it has agent ID. So we want to join team rel. Team rel, as usual, we alias it tr and we join it tr.agent ID on a.agent ID. So we want to find agent details who are on at least two teams. So now that we've joined this with team rel, um, we would not yet be able to find, at this point we can find agent details where that agent is in a particular team. But now we want to find where that agent is on at least two teams. That's so what we can do here is to join team rel twice, just so that
we can count team relationship or team ID twice for one agent. So we've joined the first one. Let's join again. But just like in the last example, when we join again, we want to change the alias. So let's call this alias TR1. So we want to join this TR1 dot agent ID to this. So the next thing we do, we write a where statement. So in our where statement, we have tr dot agent ID not equal. We don't. So not equal would be less than, greater than. TR1 agent ID. So let's run this. Oh, what am I missing? There's nothing like, okay. There's nothing like AG. Okay. So we do not have any agent that is in at least two teams. I think we're just gonna end this video here. We have done a lot. We'll end this video here, and in our next video we'll talk about um query languages. We'll talk about manipulative languages, and we'll talk about the definition languages. If you have not subscribed to my channel, please do subscribe, and I'll meet you on the next one.